All right, today we're going to talk about our properties of lines on the coordinate planes. So as a reminder, whenever you have parallel lines have the same slopes. So remember, you're going to look at your coefficient of x or your m value, and they have the same slope and they have different y-intercepts. All right, and then for perpendicular lines have slopes that are opposite reciprocals. And remember, we said that the opposites means that it's a different sign, and reciprocals means you flipped the fraction, you flipped the numerator or denominator, you switched them. And then perpendicular lines for right angles. So when you're looking here, I've got negative 2/3 and I have positive 3/2. So if I were to take negative 2/3, switch the order, I get 3/2, and then we would change the sign to make it positive 3/2. So if you notice, these two slopes are perpendicular because they are opposite and they are reciprocals, meaning you switch the order. So again, they form right angles. So I have a right angle here, and a right angle there. All right. So as a reminder, here's all the different ways you can think of slope. So change of y over change of x, rise over run, and your formulas. So what we're going to do today is we're going to do different situations. So for the first one, it says one line passes through these points, another line passes through these points. So what we want to do is we want to figure out if it's parallel, perpendicular, or neither. So in this case, when we solve the first part, we're going to find the slope. So again, I always put each part in parentheses and then I subtract them. So I subtract my y's, and these two are going to make it a positive 2, which gives you positive 4. And then I'm going to subtract my x's. Now, since I started with this 2, I have to start with this 1. And then I've got negative 1, and I'm subtracting both of them. Remember, your two negatives make a positive, and then 4 over 2 equals 2. So the slope of this line is 2, and now let's find the slope of this line. So we're going to do the same thing. So we're going to do our change of y over change of x. So remember, you're subtracting your y's to get 4, and then since I started with 4, I have to start with 0. All right, so now we've got 0, I've got negative 2, and you're subtracting. So your two negatives make a positive, and then you're going to get 2 also. Well, since we have the same slope, that means they are parallel lines. All right, so for this one, what you're going to do is you're going to set it up just how I did over here. And you're going to find the slope. And when you find the slopes, in this case, they're going to be different slopes, but they're not in opposite reciprocals. So since they're not opposite reciprocals, that means it's going to be neither. So if you do this correctly, that should be your answer. And on this one, you're going to set it up just how I have it here, but you're going to have opposite reciprocals, which means it's perpendicular. So your slopes are going to be very similar to this, where they're opposite signs, and then it looks like one is flipped. So go ahead, show your work on those two, but you should have a slope 1/4 and 2/3. And then for this one, you should have a slope of 3 and negative 1/3. And remember, 3 is 3 over 1. All right, so now let's go ahead and let's do this one where we can tell if line segments are equal if they have the same length, which that makes sense because they're congruent, they're the same. So we determine this by using the distance formula and or the Pythagorean theorem. Now remember, I like the Pythagorean theorem because it's a little bit easier to remember, but the distance formula is basically slope and Pythagorean theorem together. All right, so let's find our segment 1, which is right here. I plotted those points. So I'm going to find the length of this side, which is 6. I'm going to find the length of this side, which is 4, and plug it in to Pythagorean theorem. When I plug it into Pythagorean theorem, remember this is your hypotenuse. That's the length you're looking for. So that should be x squared. So go ahead, simplify, add those together to get 52. And you're going to get 52 equals x squared. But remember, to get that squared, we have to take the square root. And when you do that, you get x is approximately 7.21. All right. Now, if we combine, or if we do this segment and we make a right triangle, if you notice, we have the same lengths that we did here. So it would still be 6 squared plus 4 squared equals, and you could say x squared or y squared, whatever variable you want to put here. And when you did that, we're still going to get the same lengths or same measurements. So since we have the same lengths, we know they're equal. So I'm going to give you a hint on this next one. You're going to have different lengths. They're not equal. So if you did this correctly, one of these will be 7.21. The other one will be 7.07. So when you've got So make sure you're showing the work to back it up, but those are your two lengths, and since they're different lengths, they are not equal. All right, and the last part of this is just a lot of vocab, so I'll kind of zoom in a little bit so it's a little bit easier for you to pause and copy down. But a parallelogram, our opposite sides are parallel and equal. So most of us, when we think of parallelograms, we know this shape where it kind of looks like a rectangle pushed over. So these two sides are parallel and the opposite sides are parallel. All right. And also for rectangle has 4 right angles, and the opposite sides are equal. So again, when we think of rectangles, we think of shapes like this, and we know you have 4 right angles. Oops, that's a horrible right angle. That's okay. That wasn't any better. All right, and this is congruent to that side, and we know this is congruent to that side. Oh, I forgot to put my things here. So yes, so this side, our sides are also congruent on the parallelogram. All right, for your square, all sides are equal. And there's 4 right angles. Now for a rhombus you can kind of think of as a square pushed over. Kind of like it's a parallelogram, but all 4 sides are equal. It doesn't say anything about the angles there. Trapezoid, I put some pictures here already. So trapezoid, we usually think of that, or it's got your 4 sides. But what's important here are opposite. You have 1 pair of parallel sides. And a right triangle, it's a triangle that has 1 right angle. Can't have more than 1 because then that would be greater than 180 degrees. A scalene triangle would be if no sides are equal. I don't want that to look like a right triangle. Let's do 1, 2, 3. All right, so when you notice, I've got 1, 2, 3. So none of those sides are the same. All right, and for isosceles, I've got line here, line here. Oh wow, that looks like an equilateral. That's okay. We're gonna go with it, guys. All right, so 2 sides are equal, and it doesn't say anything about the 3rd side. All right, and then for equilateral, all sides are equal. Not too bad. Okay, so go ahead, make sure you copy those down. This is part of what you need to know, because then they're going to start talking about different shapes that your lines can make. And then that is properties of lines on the coordinate plane.